Assalamualaikum and hello everyone. Welcome to the video for the solution for revision question. This video will be discussing for chapter 2 thermochemistry. Okay, so without further ado, let's look for the question. Okay, the first one is to define standard enthalpy of formation, where the standard enthalpy of formation is the enthalpy changes when 1 mole of substance is formed from its element under standard condition, which is at 298 Kelvin and 180 M. So, for the standard condition here, you can't just put until this one lah. You have to mention at the standard condition what is the pressure, what is the temperature and what is the pressure. Okay, so that is for the definition. So yang ini memang nak tak nak memang kena hafal. Okay, next question is to calculate the heat of combustion of methane using standard heats of formation. So from this information, we have formation of CO2, we have formation of H2O, we have formation of CH4. Okay, so from this formation, we have to find out the heat of combustion of methane. Okay, so based upon the information, we have CH4, dah ada sini CH4. Okay, CO2 ada, H2O ada. But then we don't have any information of oxygen kan based on here. So we can't use yang delta H, betul yang product minus reactant. So what we have to do is actually we have to write down the equation of each of the formation. Okay, to find out the enthalpy of combustion lah, heat of combustion, which is this is the equation itself. Okay, remember for the combustion, 1 mole of substance is burned under excess oxygen. Okay, the heat release. So remember that for the combustion, we will form CO2 and H2O. Make sure we balance it out lah. Okay, so first, for the formation of CO2 is negative 394. So, again, macam mana nak buat equation tu? Ingatlah. So, CO2. So, originally from carbon and oxygen. Lepas tu tengok pula stable element. Okay, kalau carbon dia solid, oxygen stable element dia ni, O2 gas. And then we have to make sure that it's balanced lah. So, this is CO2 punya equation. And state the delta H. Next is the formation of H2O. Again, H2O, it means that we have from H dengan O. But then H, stable element dia H2 gas. Oxygen, stable element dia adalah O2 gas. Okay, so we get lah H2O liquid. And make sure it is balanced. Yang 1 mole of substance is formed. So H2O is the one with the 1 mole. So here must be half lah, half of O2. And last but not least is the CH4. So CH4 originally daripada carbon dengan H. Carbon solid. H must be H2 gas. Okay, this one is 1 mole. This one is sini 2 lah. Okay, so for the CH4, okay, dia dah state dia. Okay, so you have to include lah. Okay, so from this equation, you have to rearrange to get this one. You have to rearrange to get this equation. Okay, so from here, as we can see, contohnya first equation ni CH4 is on the product side. Okay, but then from the equation that we want, CH4 is on the reactant side. So we have to reverse it. So when we reverse it, sign tu pun kena reverse lah. So from negative, we become positive. For the CO2, okay, CO2 here is the product side, sini pun product side. So sama sahaja, there is no difference. So remainkan sahaja. But then for the H2O here, H2O is on the product side. But then for the equation, for the equation that we want, H2O ni ada 2. So what we have to do, this one we have to multiply all by 2. Include lah the value. Okay, once you get the equation, okay, bila kita tengok equation ni kan, kita boleh cancel out. Okay, carbon ni kita cancel dengan carbon. H2 ni cancel dengan H2 sebab opposite side we can cancel out. Okay, so O2 ni, jadi 2O2, CO2, 2H2O. So we get this equation, which is the equation that we want lah, enthalpy of combustion. Okay, so then to find out this enthalpy of combustion, we're gonna add up all the value. So we get the answer to be negative 891 kilojoule per mole. Okay, so that's for question number 1A. Okay, so 1B, so here is actually our Born-Haber cycle lah. Born-Haber. Okay, so Born-Haber cycle daripada FAL, iaitu formation, atomization, ionization energy, electron affinity and lattice energy. Okay, so here first, it mentioned for the question ni, name the enthalpies H2, H4 and H5 in the following Born-Haber cycle for sodium chloride. So in this case, the file is given to you, so you have to determine which one is which. Okay, so before anything, okay, so if you still remember, formation is from your stable element to form your ionic solid. Ni stable element kita, this is our ionic solid. So this is our one ni formation. Okay, A atomization from stable element to 1 mole of atom gas. So from this one, this equation to this equation, the difference is actually sodium solid to sodium gas. So this is the atomization of sodium, H2 ni. Okay, so from next one, kita tengok. From this one to this one, so what is actually the difference? Tapi kali ni the difference is actually, it's not our sodium ni. Beza dia half Cl2 kepada Cl. So yang ni pun adalah 1 mole of atom kan. So this is atomization tapi for chlorine. Okay. Next is kita tengok from here H3 ni atomization for chlorine. This one from sodium gas to sodium plus gas. Okay, ionization energy is that we form 1 mole of positive ion gas. So this is ionization energy of sodium. Okay, so that is H4. H5 from chlorine gas to Cl minus gas, the difference. So this is actually our electron affinity when 1 mole of negative ion is formed. Last but not least is from our gaseous ion to form our ionic solid. This one. Okay, so yang ni Miss dah labelkan each of the cycle, but then the question wants the H2, H4, H5. H2. So H2 ni tadi kita dah nampak dah. The difference is atomization of this is the atomization of our sodium. So this is the solution. H4. H4 is this one. Okay, the difference is actually from our sodium gas. Jadi sodium plus gas. Ionization energy of sodium. Last but not least is H5. The difference is that between chlorine gas to become Cl minus gas. So that is electron affinity of chlorine. Okay, so this one, to determine what is the enthalpy, you have to check lah what is the difference between the new equation ni dengan the before that one. This equation and the one before that. So from that we can know lah what is the which of the enthalpy that we are talking about. Okay, so that is for number 1. Okay, so make sure lah kena bagi tahu enthalpy of atomization tu lah specific. Sodium ke, chlorine ke. The same goes for ionization energy dengan chlorine. Kena bagi tahu for which atom. Okay, next is that calculate the lattice energy for sodium chloride. So, kalau untuk to calculate the lattice energy, sebenarnya F is equal to A plus I plus E plus L. F equal to file. Okay. So, dekat sini. Okay. Sebab ni lah ni H1 ni our formation lah previously. So, ni kita punya A, ni I, ni E, ni L. Okay. So, then you can straight away substitute the value. Okay. So, this will be the value lah. Remember, this is F. Dia yang ni sebenarnya A, I, E, L tadi. Okay, so that's the value. I believe it's quite straightforward lah yang ni. Okay, last one pula. Next question number 2. Okay, question number 2 here, it mentioned that the enthalpy of combustion of fructose is 21.2 kJ per mole. An amount of 2.63 gram of fructose was completely combusted in bomb calorimeter at 25 degrees Celsius. Okay, so write the thermochemical equation for the reaction. Okay, so remember that enthalpy of combustion when 1 mole of substance burn completely in excess oxygen. Okay, so bila kamu buat equation, we have O2 and CO2 H2O. Okay, for the balancing ni, hint dia first adalah balance kita punya carbon. Next is balance kita punya hydrogen. Last but not least is balancekan the oxygen itself lah. Okay, so make sure sebab contohnya kan sini 6, so sini 6 carbon. Here 12, so here 6 to get 12. So contohnya dekat sini ada 18 oxygen. Okay, it does not mean yang ini jadi 9 O2. Because remember, here we have 6 oxygen. Okay, so maknanya sini it will become 12, 6, so 18. Okay, sini dah 6. So, kita kat sini nak 12 lah. So, that's why we get 6 O2. And make sure state our equation must have the state lah. Solid ke, gas ke. Okay, so how do we know that fructose is solid? Kita punya sugar lah. Macam tu Okay, and then you have to include delta HC ni pun kena tulis juga for the thermochemical equation. Sebab the information is given. Kalau dia tak bagi, then we don't have to include lah delta H. Okay, question number 2 is that calculate the final temperature if the calorimeter contains 225 ml of water. Okay, so yang ini, question ni, dia banyak step sikit sebab macam kita kena retrace back the steps. Okay, so final temperature ni we get from our delta T. Okay, so delta T ni kita dapat daripada mana? Delta T ni is actually we get from our Q. Okay, kan ada Q MCAT, Q CAT, Q MCAT plus CAT, semua ada kan? Okay, but then where do we get our Q? Dalam information yang ada, based on this question, what we have is ni enthalpy of combustion. Here is our delta H lah. Delta H combustion. Okay, tapi sebab kita remember delta T daripada Q. Q ni kita dapat daripada kita punya delta H. Dia macam ni pula. Okay. So, but then delta H kita dah ada. Delta H ni is for 1 mole. Okay, tapi sekarang ni dia ada bagi 2.63 gram of fructose. So we can find the number of mole of fructose first. Okay, yang inilah yang kita selalu guna. Delta H of combustion equal to Q divided by N. So combustion dia kilojoule per mole. Q dia is the one that we're going to find out. Sebab nanti kita nak cari delta T from there. And then mole ni is actually when I divide lah my 2.63 gram ni. Okay, so the Q will be 0.3095 kilojoule. Ataupun terus buat 309.5 joule lah. Okay, so yang ini kita selalu guna. Ataupun you want to use the cross multiplication pun boleh juga. Tapi suka guna ni lagi lah. Okay, so we do get our Q. So yang Q ni I would prefer to use in joule. Sebab nanti kat sini CW ni kita guna 4.18 joule punya. So, tukarkan terus kepada joule. Okay. This is Q. Tapi, sekarang ni, information yang kita, from Q, we have these choices kan? Okay, so, W ni is for water. Okay, C ni stands for calorimeter. Based upon the information given, we don't have any information of calorimeter, tak ada. Tak ada langsung lah. But what we have is actually pasal water. Okay, water ni we get volume dia 225 ml of water. Since density of water is 1 gram per ml, kita akan assume mass of water adalah 225 gram. Okay, so this is 225 gram. Ni adalah. Okay, so tapi kita punya formula mesti Q equal to M CAT. Dia bukannya terus Q equal to MAT ni bukan. C ni is our heat capacity. Even though it does not mention specifically in the question, tapi in the exam, in the list of constant, we have our CW ni, 4.18. Okay, so when we substitute the value straight away, ni bukan 0.225. Here dia jadi 225 gram. Then we get delta T to be 0.33 degrees Celsius. Then from delta T, remember that delta T is T final minus T initial. Okay, initial temperature it is given in the question. Dia kata dekat sini, amount of fructose was completely combusted in bomb calorimeter at 25 degrees Celsius. Okay, so kita substitute sahaja, then we get the temperature to be 25.33 degrees Celsius. Okay, so that is for question number 2. Okay, next question. Question number 3. Question number 2B. Okay. Calculate the heat release when 0.75 nitrogen dioxide is produced in the thermochemical equation below. Okay, so kalau kita tengok dekat sini, so NO2. So this is our NO2 lah yang kita interested in. So, when 2 mole of NO2 is produced, what we have is actually 114.1 kilojoule. Okay. Tapi kalau 0.75 gram, berapa pula? Okay, so what we're going to do first is actually find out the number of mole, 0.0163 ni. Okay, 0.75 divided by molar mass, dapat 0.0163 mole. Again, molar mass ni nanti is given in the list of constant, dalam exam dia beri. So, dari sini kamu boleh terus buat cross multiplication. 2 mole produce 114. Kalau 0.0163 mole, you get 0.93 kilojoule. Or, contohnya, if you want to use yang delta H is equal to Q over N. If you want to use delta H is equal to Q over N, boleh juga. Tapi delta H ni is actually for 1 mole punya. Okay, so if you use this one terus, masukkan this is your delta H. N ni kamu masukkan this one, you won't get the answer lah. Sebab yang ini mesti 1 mole. So what we're gonna do, first we divide this one. Divide this equation, divide by 2. Okay, so then we get 1 mole of NO2. So yang ini boleh masukkan sini. N kita ni, we get 0.0163 mole. Maksudnya dekat sini, it will be negative 57.05 divided by Q, equal to Q divided by 0.0163. Q, you will get, berapa tadi? 0.93 kilojoule. Okay, again, this is the cross multiplication. Kita guna formula yang inilah. Okay, why we can't use delta H straight away? Yang ini masukkan. Sebab this one is actually for 2 mole. Kalau nak buat guna ni, make sure yang ini nak jadi 1 mole. So, divide lah all the equation as well as the value. Okay, so that is for question number 2. 2B ni is quite straightforward. Okay. Okay, next question. It's actually question number 3. Okay. Construct a Born-Haber cycle for CaF2 in the solid state by using the data below. Calculate the lattice energy. Okay, previously, in question number 2, the Born-Haber cycle is given to you. But in this case, it is not given to you. So, you have to write down the equation first and then you have to construct the cycle. Okay. So, remember for the Born-Haber cycle, it must be phi L. Okay. F is the formation, must be from our stable element lah. So, CaF2 must be from calcium solid plus dengan F2 gas. Okay, so this one is already balanced, so this is our formation. Atomization when 1 mole of atom is formed from stable element. Okay, so this is actually atomization of kita punya calcium. Okay, tapi dekat sini ni bond energy of FF bond. So, what is actually bond energy and what is the difference between bond energy dengan atomization? Okay, kalau atomization, contohnya lah. Okay, atomization is actually when 1 mole of atom is formed kan from stable element. Stable element dia F2. Okay, tapi sekarang ni is not balanced yet. Yang ni yang kena 1 mole. So, here you will be half lah. So, this is atomization kita. Tapi bond energy, okay, what does it mean is that from our F2 to F2 ni kita nak break the bond. So macam tu lah. Yang ni dia F ni kita break jadilah F plus F. Ataupun cara yang lain untuk senang kita tulis macam ni sajalah. F2 gas jadi 2F gas. So the enthalpy of atomization and bond energy is two different things lah. So dalam kes ni for our question dia nak bond energy. Okay. So, bond energy is this one, yang ni lah. Okay, this is atomization. Atomization, dia nak bond energy. Ini memang tricky question lah. Okay, so that is for our, akhirnya for our file ni, F dengan A dah settle. Okay, so for I is ionization energy from our gas nak form positive ion, our cation. So, for the first one, Ca gas jadi Ca plus. Kalau second ionization energy from Ca plus jadi Ca2 plus. And then our electron affinity is our when 1 mole of gas tu dia akan accept electron to form F minus gas. Okay. So from there we can draw the bond Haber cycle. So here is our F. Okay, so this is atomization kita. Okay, again remember for the bond energy ni, sebab this is bond energy kan, F2 kepada 2F. Which is this is the equation that we have written down. So yang ni tak perlu darab 2. Yang ni dah memang ada 158. So ambil sajalah 158. Okay, but then for the electron affinity, since dia adalah F2 gas jadi F minus gas, but here sebab ada 2 kat depan ni kan, because we have 2 in front of here, so we have to times dengan 2 lah. Sebab equation sini baru 1 saja. Sini 1F, 1F. Okay. That is for our E. Kalau yang I tu, again, buat step by step. Ca plus gas, Ca2 plus gas. Yang ini, senangnya, make sure ya Ca2 plus gas ni dengan 2F minus gas ni at the same. Kalau kamu buat kat kertas kajang, maksudnya dekat line yang sama lah. So that you can write down plus dekat sini. And then, terus form kita punya CaF2. So, this one is actually our lattice energy. This one. Okay, so we can substitute the value straight away, and this is the answer. So rasanya, if you didn't get the answer, I think it's because of this one lah, yang bond energy ni. Make sure bond energy ni is very different from atomization. Dia tak adalah very different, dia ada slight different kan, kat mana yang jadi 1 mole tu. Okay, but so bila dia berbeza, so the value will be different lah. Electron affinity ni yang kena darab 2. Bond energy no need to multiply by 2. Okay, so then from here barulah kita boleh calculate the lattice energy. So this is the solution. Okay. Okay, next question. The same question lagi, question 3A ni. What would you expect the lattice energy of sodium chloride compared to that of CaF2? Explain your answer. Okay, for the CaCl2 and CaF2 ni kan. Okay, for the lattice energy, there are 2 factors affecting it. One is ionic charge, second one is ionic radius. Okay, so charge Ca ni Ca2 plus, Cl minus. Ca ni pun Ca2 plus, F ni pun F minus. So we can't compare it in terms of ionic charge lah. We can't. So what we have to do is we have to compare it in terms of ionic radius. Okay, so calcium dengan calcium sama. So we have to compare it in terms of chlorine dengan fluorine. Okay, yang ini dia macam kena fikir sikit, kebat sikit So for group 17, down the group, this is the element down the group. Starting from chlorine, bromine, iodine. Okay, and then down the group, radius will increase because shielding effect increase. Attraction between attraction between the nucleus and the valence electron pun decrease. So that's why lah radius they increase. Okay, so what happened now? What happened is that chlorine will have a higher ataupun the ionic radius for the chlorine ni is actually higher than fluorine. So bila dia punya what do you call that? When the radius dia is bigger than fluorine. Okay, but then for this case of lattice energy, dia inversely proportional. Okay, so it means that sebab dekat sini CaCl2 ni higher radius, radius besar, so lattice energy is smaller. This one radius dia kecil, so lattice energy dia is bigger. Okay, so dekat sini lah mention lattice energy of CaCl2 is lower than CaCF2 because the ionic radius of F minus is smaller than Cl minus. Ataupun you can also write down ionic radius of Cl minus is bigger than F minus pun boleh juga. Then F minus. Okay. Then remember lah, ionic radius is inversely proportional to lattice energy. Okay, lattice energy ni is actually strength of your ionic bond. Okay, so contohnya we have our calcium, radius dia sama. Okay, kalau F tu dia kecil sikit. Okay, so radius dia akan jadi this will be the ionic radius dia lah. This is Ca, ni Ca apa ni? CaF2. Okay, kalau CaCl2, okay, assume je lah macam sama. Besar lagi sikit. Okay, so yang ini sini. So as we can see, sebenarnya CaCl2. So ionic bond for the CaF2 ni is stronger lah sebab dia lagi dekat kan. So ionic bond dia tu is more stronger bandingkan dengan CaCl2. Okay. Okay, the last question. Okay, yang ini question ni macam kalau kamu ingat, this is your experiment for your calorimeter tu. Eksperimen dia senang, calculation itu yang pening sikit. So here mention 100 ml of 2 molar hydrochloric acid and 100 ml of 2 molar potassium hydroxide solution are mixed in calorimeter with the initial temperature 30 degrees Celsius. And the maximum temperature of the solution is 41 degrees Celsius. Okay, calculate the heat enthalpy of neutralization lah. So enthalpy of neutralization is the heat release divided by number of mole of water. Okay, for the neutralization ni, dia memang step by step. First, we have to write down the equation dululah. Equation between our acid and our base. Okay, so from there, kita akan carilah mole of HCl dengan mole of potassium hydroxide. Okay, kenapa? Sebab kita nak cari limiting reactant to know the number of mole of H2O. But since we have equal number of mole, so kita akan assume teruslah number of mole of H2O sama sahaja dengan HCl ataupun NaO, which is 0.2 mole. Yang ini yang panjang sikit step dia. Okay, which is from this one lah. Okay. Next is N dah dapat. How about Q? Okay, since the information here we don't have any calorimeter, so kita akan gunalah kita punya water. Okay, so for the water itself, Q equal to MCAT. CW ni is actually a constant, 4.18 lah. Okay, delta T is final minus initial, 41 minus 30. Okay, how about the mass? Mass of water. Okay, mass of water tu kita akan ambil daripada volume of water. Okay, sebab sini kita ada 100 ml of HCl. Okay, kita assume saja ni 100 ml co. So, kita assume volume of H2O pun 200 ml. Sebab kita dah reactkan our acid kan base kan. Okay, so since the density is equal to 1 gram per molar, so mass of water we will take it as 200 gram. Okay, so this is the substitution. Then you get your Q. Tapi itu baru Q. Heat the heat release kan. Okay, but then we want to find out the enthalpy of neutralization. You want to know the heat release per 1 mole of H2O. Okay, so daripada sini kita tahulah Q is this one, N is this value. Okay, so yang ini divide by 1000 ni sebab nak terus dapat kilojoule per mole. Okay, kalau tak nak buat, then you will get negative 45,980 joule per mole pun diterima juga. Okay, so it's either this one ataupun okay. Kalau ini kita akan terus dapat we will get 48,980 joule per mole. Negative ni you have to add yourself because to show that heat is released. Yang ini memang kena tambah sendirilah. If you don't have any negative sign, kita salah. Okay. Okay, so that's it for the video for the solution for chapter 2.